Uh, good morning. Good morning to all. On behalf of Qcrete Readymix India Private Limited, we welcome Mr. Vikram Tamvekar for this webinar, which is 12th in our Qcrete webinar series. Just a few words about Mr. Vikram Tamvekar. He's a well-known structural engineer in Mumbai. He has a lab to run detailed tests on building materials, and he is currently CMD of Quantec CCRC Private Limited. He is having more than 35 years experience, and he is highly experienced in construction, structural design, consultancy services in concrete, management services, structural audits of buildings, structural rehabilitation consultancy to many government projects. The list is very big, and it cannot be captured in few words here. Most importantly, other than his experience and expertise, knowledge, actually, he is one of the most beautiful human beings I've seen and I've met, actually. And he's more like a friend to any of his customer or client and things like that, actually. And it is unbelievable that he is very, very humble with, I can say, a mountain of knowledge. We welcome you, Mr. Welcome Tambekar, for this webinar, and we are fortunate in Qcrete to have you on our webinar. Thank you, sir. Please start.
Thank you, Mr. Kaushik, for a good introduction. And important thing is that thank you very much yourself and Qcrete for giving me this opportunity to share my knowledge, experience, and some topic about this today's topic. And and a very good morning to all these attendees, dear friends, all these professionals, ladies and gentlemen. We start. We'll go ahead with the presentation. Hello.
We are hearing, sir. We are hearing.
Yeah. See, our today's topic is the effective use of concrete for RCC structures. See, this concrete subject itself is a very vast subject, which you have already explained to in from your various seminars. You have explained all about these admixtures, making good concrete, using good concrete. In last webinar, our respected Faisal explained about use of microfine materials and etc. Now the point will come, how extra things I'm going to be tell to my all these attendees. The point is here, see, all the attendees today, they are the professionals and they know this concrete subject very well. And instead of highlighting all these basic things, I'm going to be enhanced, or I'm going to be explain about what is right and what is wrong for this structural use of concrete. See, generally in construction, see, concrete is a very vast and very important material to be used in construction industry, where suppose in any building, about 40 to 45% material is used as a RCC, that is a concrete and steel, and out of that RCC frame, use of steel is limited. It's not more than 3 or 4%. So almost 40-45% use of concrete is going on. So we have to take extra care for concrete, and that care is for making fresh concrete as well as using this fresh concrete, and some care to be taken after for this hardened concrete. See, we'll go ahead. Yes, पुढे काय नाही slide. Hello. Hello, hello, anybody is here? Can be
Yeah,
here?
yes, sir.
Yeah, yeah. See this concrete, what is the concrete and other things that will not discuss much more, because concrete is such a thing, that material which is a composite material of fine and coarse aggregate bonded together with fluid cement that hardens and cured for over a time to get a high strength and other things that everybody knows. So we'll not discuss much more on this ingredients, basically type of cement and etc. Now the point is here, use of water for making fresh concrete and using a water for water curing is very important, because I have seen in Mumbai area some failures are because of the use of water. Because see, instead of I can't tell you the name of project, name of location, etc. But can share this experience as a case study. One building, multi-story buildings, about say uh, five, 6 floor was completed, and there was some failure of cubes, and we tested all these framing material by extracting core and other things. Then we and after analyzing all this material, we came to know that all this concrete which was used for that RCC frame structure was containing high amount of chloride content, and that happened because of these local people. They use bore water or well water. Well and bore was close to creek area. So instead of checking all this water quality, they straight away used it, and they found some problem with the concrete at early age, very early age, because the building was under construction. So it is very important to use fresh water and test the water before using directly. And care has to be taken for the projects where water is supplied by tankers, because at many sites tankers, the water supplier people, they submit the test certificate from different water and they supply material, water from well or something. So we'll have to take care that contaminated water should not be used for any making any fresh concrete, as well as using for curing also. If anybody is using curing compound, care shall be taken that all the surface should be moist before applying the curing compound. Then use of cement, minerals, chemical additives, that already explained very well by Kaushika sir in his last seminar. Whereas I want to say, using quantity of admixture, if it is not in a proper proportion, then it may give some adverse effect also. So use of admixture, chemical admixture should be limited as per specification, and before using such a chemical admixture, one should use it. One should test it for its compatibility with the cement which is being used. So this care has to be taken for making fresh concrete. And while making fresh concrete, the sequence of putting material in a mixer, either in a RNC plant or in a batching plant, or say some of these regular mixer at site, sequence should be used properly so that all the pest and fine and coarse aggregate will get mixed to get a very good quality of fresh concrete. And to get all this flowable and workability, what the admixture we are using, it should be used in a proper way. Before using all this chemical admixture, it should be stirred well so that all this solid contents of chemical admixture should be mixed with the concrete or mixed with the water. If you are using water and chemical admixture together, it gives better effect. Then behavior of hardened concrete, that everybody knows, that compressive strength, tensile cell, bond strength, flexural strength, E value, and so many things are there that we are regularly testing it. and then actually we have to test. I mean, test so many tests to get a proper strength of concrete. And we'll see further the factors affecting strength of concrete and etc. There are n number of reasons to make a good concrete, and of course there are n number of reasons to uh, lower the strength of concrete also. So these things are mentioned on our slide. So instead of reading all these things, I'm going further, because the use of fine aggregate, volume of paste, etc., that everybody knows it. The temperature effect and percentage of identities are also very important factor for making a fresh concrete. Because see, I have observed at one site one very reputed company and reputed concrete suppliers. A higher grade of concrete was used, and there was a not a final setting for more than 30-40 days or 60 days. And when we saw that there was a final setting was not taken place, so we came to know that it happened because of the excessive use of chemical admixture. So that making a fresh concrete, the use of chemical admixture should be restricted, and as per compatibility of concrete itself. So for making a fresh concrete for higher grade concrete, it is necessary to conduct trials at site, and then go for making a fresh concrete for regular use in framework. The type of concretes are so many concretes are there: plain concrete, normal strength concrete, high strength concrete. See, normal strength concrete is generally nowadays in for RCC about 20 to 40 is the normal grade, and below that M20, these are the regular concrete for using PCC and other things, that is for non-structural use. So plain concrete, normal strength concrete, high strength concrete, then high performance concrete, ultra high performance concrete, early strength concrete, roll compact concrete, reinforced concrete, ready-mix concrete, stamp concrete, self-compacting concrete. There are so many concretes being used as per the project requirement. Especially this lightweight concrete. Use of lightweight concrete is required where in some special cases where as per the design of consultants, where it is essential to go with the lightweight concrete but with a proper strength. Here I want to tell you all these attendees that I have provided a design for lightweight concrete, and which was used for making a canoe. Canoe was casted by some college students to send it in a competition. That international competition was there in USA. So we constructed one canoe with a lightweight concrete in Mumbai, in one college, that Mukesh Patel Engineering College in Andheri. So that canoe size was 450 mm wide by some 5-meter length, and wall thickness of that canoe was hardly 40-45 mm. And that canoe was tested in a lake. It was floating very well without any problem, without any leakage, leakage of water and etc. And that density of lightweight concrete was only 1100 or 1150 only. So these are the things. High density concrete is, of course, it is being used for foundations and others, and only in special cases. Then polymer concrete, people are using some amount of polymer in that, which is, of course, that use also depend on project requirement, air entrant concrete and other things. Vacuum concrete or Readymix concrete. I want to explain here about Readymix concrete is that for all these industrial warehouses or industrial flooring, people are using Readymix concrete in large quantity. But I generally suggest all these users that avoid using Readymix concrete, because see, for the people are using Readymix concrete as they add more water in concrete and placing the concrete, and thereafter they are vacuumizing the excess water and making it hard. But in our concrete technology, using more and more water, you are increasing the water cement ratio, which of course disturbs the strength of concrete. So adding more water in concrete and then removing this water after some times, it makes you are making number of pores in that trimix floor area, from the concrete, which is used for this flooring purpose. So this technology of trimix concrete is not much more advisable, of course. Then pump concrete. Pump concrete is required some slope, I mean a slump of minimum 150 and a maximum up to 250, 300, 400, depends on length of pipings and height of piping or a structure where you are placing the concrete. Especially here for this pumping concrete, I want to tell our friends to avoid this pumping concrete or pumping of concrete in hot sun when temperature is very high, say about 35 degree or something, because what happens, all these MS pipes gets very hot, and even though there is a very good flow in concrete, fresh concrete, very good workability in fresh concrete, that because of the heat of hydration in the concrete, which is coming through the pipes, start setting early stage, and finally it becomes it goes on setting, so there is a difficulty for pumping. So either you have to cover it with the gunny bags with water immersion, or with the water, or better to use such a RMC or concrete when there is a very low temperature. Ambient temperature is a very low. Low means up to 30 degree or 32 degree. In very hot ambient temperature, try to avoid the pumping of concrete. Then further, geopolymer concrete is of course in R&D stage. Now we can use it for other purposes other than structural use. This durability of concrete is also very important aspect of use of concrete. For all these high-rise buildings, various tests on durability of concrete is being followed everywhere. In Mumbai area, for all these high-rise buildings, very reputed project exhibitors, they are following regularly to test the durability tests, like RCPT, then water permeability, ISAT, then drying shrinkage, so many things. Because if better test on durability is not taken, there should not be any problem for this durability, as it is a very important factor for these high-rise buildings. The factors affecting durability of concrete is depend on various parameters. That is, of course, cement content, then other binder content, quality of aggregate, quality of water, and use of admixture, type of admixture, etc. See, when RMC supplied at site fresh concrete of very good quality, if proper precaution is not taken to discharge the concrete properly, and making a good compaction, making a very good curing, etc., durability affects, as well as strength also affects, and finally durability also affects. So we'll have to take care for all these practical uses of concrete at site, even though very good quality of fresh concrete is delivered at site. Because I have seen, because of the wrong application at site, there are many problems has arisen for the structures. And of course, curing is also very important factors. All project people should use only potable water, or if other well water or bore water is there, its pH and other parameters like chloride content, sulfate content, and so many things, which is laid down in 4/6 should be checked properly, and then only water can be used to make a fresh concrete or for curing also. Permeability, that this of course this is related with the durability. If you are checking the permeability of concrete, if high permeability is there, then of course there is a reduction in strength of concrete. So make a proper concrete with the proper design, proper compaction, and proper cover, etc. There are so many things which, of course, many people knows it very well. Again here the point has come that water quality. That quality of water is mentioned in IS code, that it should be pH should be falls within the range of 6 to 8, and instead of going for all this, the water which is used for drinking shall be used straight away to make a fresh concrete, as well as shall be used for curing purpose. Then other factors affecting the durability, that is the moisture content, abrasion, carbonation, wetting and drying cycle, alkali aggregate reaction, silica alkali reaction. See, in Mumbai region and in most part of the India, apart from this North Indian part, we are getting very good quality of aggregates, that which we are using for making a fresh concrete. Here we find better quality of aggregates as a basalt stone is available, whereas in North region, at many places, the stone quality of aggregates are not good. At many places we observe it contains some amount of silica, so such type of aggregates shall not be used. This particular precautions has to be taken where project is going on in North India, especially in North India. I have visited some sites and observed good quality of aggregates are not available. But rest part of India, we are getting very good quality of coarse aggregate and very good quality of natural sand also. In Mumbai and surroundings area, and in many places in Maharashtra. Nowadays river sand is not available, and people are using manufacturing sand, or in other words, this is stone dust or crushed sand. While using crushed sand, it has to be tested for a sieve analysis instead of using blindly. And if better quality of crushed sand is not available, then use of crushed sand should be limited as per the mix design requirement, or to meet the other parameters of the fresh concrete and better strength level also. So this factor is also very responsible to make the good quality of concrete. Secondly, precautions for rough foundation casting. See, for many high-rise buildings or industrial buildings where rough foundation is there, and rough foundation with larger size and where depth is quite big, that is above 1 meter, 1.5, 2 meter, 3 meter. In Mumbai, for high-rise, we have seen some depth of rough foundation was 2.5 meter up to 3 meter also, and so it's not possible to make a concrete in one stroke for all this volume, because the volume of concrete is very high. So concrete is being poured in some different stages, or at site some pockets are prepared, or some areas are prepared to provide the concrete for this rough, as the volume is very high. So while putting this fresh concrete in a high volume amount, it is necessary to check the temperature of fresh concrete which is poured in a high volume, because of the high volume of concrete, the CSS gel forms, it creates a very high amount of heat of hydration, and due to heat of hydration, there is a chances to develop the micro cracks or hair cracks in a concrete due to heat of hydration. To control the heat of hydration, in many mix designs, fly ash GGBS is being added, And of course, before using all such a cementous material, necessary trials should be conducted to ensure the strength level as well as heat of hydration and this air content also. So temperature monitoring is a very important factor for this raft foundation, because in other cases, see large size of columns and of course beam and slabs are not much more bigger, but when girder is there, but instead of putting a concrete in a large volume in our this retaining wall or say lift wall or somewhere, this wall itself is designed as a RCC member. So at such a member, concrete should be done in a stages, not more than 1 meter height, to avoid all this problem of heat of adhesion, as well as compacting the concrete in a very good degree. Nowadays there is a one terminology as being followed in a field, that is a performance based concrete. Now anybody will ask, what is a performance based concrete? Some consultants assume or say they insist to put some amount of silica fume, alkofine, GZBs, etc. apart from OPC or PPC. So how it gets benefited? Of course, that benefit is very limited when these additives are used up to 10%. But if you are going beyond that, it gets benefited to certain amount. But whether it is required or not, for up to 40 M40 concrete or M50 concrete, as far as my knowledge concerned, it is not required at all. If we are using a very good material and a proper mix design. See, we have produced up to M50, M55 grade of concrete using any, not using any the cementous supplementary product such as silica fume. Only fly ash we have used in a certain percentage to get a good workability and good pest to have a good finish and good strength also. So for making a performance concrete, it is not advised to go with the additional use of supplementary material like silica fume or GG base, etc. But when there is a high volume of concrete being used for this raft foundation, use of GZBS, alkofine and fly ash is of course it's now common use, shall be used to get a better durability. And of course that durability doesn't find immediately because of the reaction of this cement reactivity of the supplementary material. It starts after some periods, that after 28 days, 30 days, 45 days or something. And all these durability parameters should be checked up to 2 months, 3 months, etc. to ensure that what is the effect of hardened concrete. So these are the tips for performance based concrete. And generally concrete up to M40, I don't think use of other supplementary material other than fly ash is required. Yeah. Further, when we are putting a fresh concrete in projects, we are casting RCC frame structure. Somewhere what happens, people get less compressive strength at site as they cast the cubes of the fresh concrete. But casting of cube with the fresh concrete is also very important. If anybody is not casting cubes properly, even though fresh concrete supplied at site is a very good concrete, because of the wrong practice of casting the cubes or not compacting properly the cubes as per the methodology, that is 20 strokes, 30 strokes, and if the cubes are not of proper shape, or if that cube mold itself is not tightened properly, so that shape gets disturbed. And secondly, if cubes are not casted properly and not cured properly, it directly affects the strength of concrete. and then people worried about, अरे इसका strength इतना आया, ये आया, क्या हुआ, क्या नहीं. So to ensure what the concrete has provided in frame, like a beam, column, slabs, or foundation, etc., there is a procedure to check some test at site that is called non-destructive test, that everybody knows it. But while doing the test of NDT on fresh concrete, as well as when you are doing the NDT on old structures, there are different methodology. And commonly test on this for this NDT is rebound hammer, ultra pulse velocity. Then for all structures, test of carbonation, test of corrosion is also required. But for fresh concrete, only rebound hammer and UP is required. So with the help of rebound hammer, we can determine the apparent value of compressive strength, and then we can decide whether this concrete is acceptable or not. As well as with the help of UPV, we can determine the density of concrete. Because if concrete is not properly compacted, there are chances of honeycombing or some porosity in concrete section, which can reduce the strength of concrete. So it should be, with the help of NDT, it should be determined, and proper remedies can be applied on that. See, there are method of using UPV on fresh concrete as well as on old structures. See, some pictures are here. People are doing UPV on RCC column. What the process here followed is a direct method, and another method is indirect method. So indirect method, there are different calculations, and of course some amount of 1 kilometer per second velocity is to be added, which was given in SP 23. Now that factor is also removed. So as far as possible, better you check the UPV test in a direct method, and wherever it is not possible to have this direct method, anyone can go with the indirect method. And reading should be taken properly. All these measurements of distance should be used properly, measured properly to calculate the UPV values. Secondly, this UPV test is being conducted on all structures, either rebound hammer or UPV. See, you can see here in slide the one picture, the person is following this rebound hammer test on old RCC column. Here we have removed all this plastered material or finished material from the RCC member. I have seen at many places, many people are using hammer test directly on the plastered material, or they are following UPV test directly on the plastered material, which is totally wrong, because we are not testing the finished material, but we have to test the original RCC structure to see the position of the structural member. So these precautions anyone should take to remove all this finished material, to make the surface preparation properly by making the surface smooth, removing all this greasy or oily material, etc. These things are very important to take care about the testing methods. See, here I'm purposely I have kept some pictures here of used concrete, fresh concrete, which we use for some projects. Actually, why I have kept this picture here, because all this concrete we prepared at site, in situ concrete, with the local material, and without admixture, because admixture was not available in some rural area, in coastal area. So we made a fresh concrete with what the material was available. See here, in this picture, I can show you the picture of one bungalow where there was no provision for car porch, or there was no porch at all. So owner insisted, is it possible to make the porch on these existing columns? I said, it's definitely is possible. So using all these existing columns of a normal design, say 300 by 300 or something, we provided a beam over it, and from that beam we designed that beam and slab in such a way that we can cast the cantilever span of some 5 meters and length was about some 6 meters or something to have a car park in that. Here I want to explain you that even though in local area, local material, we use a very good fresh concrete by controlling water cement ratio and a proper proportioning of the local material. And this site is a very close to the sea. It's at a coastal area in Raigad district of Maharashtra. And this particular canopy is still there without any problem, without any cracks and other things. Of course, very light section we have used. That thickness of this cantilever slab is limited to the 150 mm to 100 mm, and grade of concrete not more than M25 or something. Why these such type of structures being remain standstill or being without any impact of fatigue? The reason is only to produce a good concrete and provide such a good concrete with the proper compaction, proper curing and etc. Then only we can get a good results here for such type of structures. See another picture here. These are all this big building we have I have shown here. That is a cantilever span of 6 meter and 4 meter. And this particular hotel building or resort building is coming up very close to sea. It is sea is hardly 500 meter from our site, and these structures are on some hillock. And this bigger cantilever happened because of the changes in designs. So instead of providing additional column, we straight away forward to go with the cantilever structures. And grade of concrete what was used is only M30. But you can see here all the finishing of all these formworks and everything is a very fine. And after de-shuttering, removing all these props and everything is fine. And the age of today this structure is about 1 year. Nothing is wrong, nothing has happened with that. The results we get to withstand such a structure without any cracks, without any fatigue and other things, only because of the quality of good concrete, fresh concrete, and degree of application, that is placement, compaction, curing and etc. So even though we produce a very good concrete or we procure a very good concrete from RMC plants, and we are not using such a concrete in a proper way at site, many problems can happen. And one should not, instead of blaming to the concrete supplier, we'll have to see what the thing was wrong at our site, how the people have worked or how the people have executed the job. I'll show some other photographs also. Because of the wrong application, there was a number of structural problem happened at site. At one site, hello. See another picture we can see the cantilever canopy is also there. That this canopy is constructed for a hotel building is about 4 meter span, and its length is about 15 meter. It's in different architectural shape. And important thing is here that thickness of this projected portion or projected cantilever portion is only 100 mm by 150 mm only. It's a very sleek. And we use the fresh concrete at site with the local material, local laborers, with the ordinary drum type mixer. Here I want to show you that or explain you that making of fresh concrete in a proper proportion, in a proper way, with the proper control of water cement ratio is a very important. Then only we can get a good result of such type of larger span members or a larger span structures. So while making fresh concrete, all these necessary precautions must be taken, or I'll tell you here at our Dapoli project, we didn't get better quality of coarse aggregate, and even river sand is also not good quality. It was containing some large amount of silt, as well as some flaky material, 10 mm down or 10 mm aggregates and 20 mm aggregates was also flaky. So to avoid all this effect of flaky material and to get a good cohesive material and good strength of concrete, we use better mix design. After analyzing all this material in our laboratory, and we gave the mix design in a such a way that we got a very good strength as well as a good finish also. So mix design is also very important parameter or important factor while producing the fresh concrete. In our next slide, we can see here this bungalow is constructed at Daman. It's at coastal area itself. And in last slide, what I shown this picture, it is also in coastal area. In this Daman, this particular bungalow owners, he said me, I don't want any beam inside my this sitting area. I don't want any beam on my head. I said, okay, we'll do it, because he said under any circumstance I don't want beam at all. And this sitting area is having span of 10 meter and some length is about to say 6 or 8 meter. It's a big hall of bungalow. To avoid this beam, I have provided 10 meter length or 10 meter span hidden beam with the sloping slab on this sitting area. The thickness of this entire slab is only 150 mm, and we have provided a hidden beam for the span of 10 meter. Here I am emphasizing you that this particular effect of hidden beam slab is possible with the only using good quality of concrete, because if you provide more and more steel and concrete quality is not good, nothing will happen. There will be a definitely deflection or there will be definitely failure after a certain period. So to avoid all such incidents or all such problems, we have to produce a good quality of concrete, and then good application is also equally important. If application is not good, then definitely use of making a good concrete is also not useful at all. Making a good concrete, placing a good concrete, compacting a good concrete, and of course curing factor. If we are not cured properly, regularly, frequently, then we won't get a good strength. At site, what happens? People just sprinkle the water for certain time and then leave as it is. But and whereas the cubes we are putting in a water for 24 hours. So there is always difference of cube strength as well as the strength available at the site, or strength of material provided for beam column slabs are little different. So to get a good strength of concrete at RCC members or RCC frame, following a good practice of continuous curing is a very important. Curing factor is also very important, because even though there is another method of applying a curing compound, it's not possible to provide a curing compound for all the structures. See in another picture, I have placed here this one picture where we have provided cantilever sloping roof that is spanning about 5.5 meter, and this width is about 7 meter. This is also long lasting without any problem, and it gives a very good aesthetic view. This happened only because of the providing very good quality of concrete and very good application of concrete. See one more important picture here I have placed. This is the staircase of spiral staircase. See spiral staircases you can observe at many places which are generally being placed of this steel structure or cast iron structures. Here we have made a spiral staircase in concrete. That concrete is of course special concrete. What I use word special concrete because here the person who has made this formwork is also very important. That credit goes to him also. Whereas for this mix design point of view, we have used only 10 mm down, means 6 to 8 mm size aggregate by getting it, sieving it from 10 mm down, and of course cement content and some mineral and chemical additives was there. We have used it, and the steps of this all this spiral staircase is only 75 mm thick, only 75 mm thick. You can see here it is a staircase before finishing of staircase, and this another picture shows after finishing of these all steps by providing wooden top of at trade and other things, and it looks very beautiful and a very beautiful architectural and aesthetic view also. Hello. See, thereafter I want to discuss what causes failure of concrete structures. That of course in before slide also I have at some level we have discussed. Incorrect selection of concrete materials also may be the main reason of failure of concrete, as well as errors in concrete mix design calculation and preparation of fresh concrete, improper construction techniques and insufficient quality control and supervision. That was of course we discussed placing of concrete, compaction of concrete and etc. Then chemical attacks on concrete structures, incorrect construction joints, poor compaction, poor curing, chemical attacks due to chloride, sulfate, acid, carbonation, alkali reaction, etc. These are the main parameters. In our next slide, we'll discuss about the joints. See here, some pictures are there. Here some pictures. See, I'm showing this picture. See, there is a supply of RMC from RMC supplier, and people are using in a wrong way to cast the staircase. See, this mixer is standing at higher level, and the place where concrete has to be discharged at lower level, and of course that distance is more than 2 meters or something. Here we can see the concrete is being discharged from the height without any using any chutes. What happens with the when we are discharging a concrete material from higher, that all that cohesiveness of concrete gets lax, and all this coarser material gets separated. So indirectly we can say segregation takes place. So because of this wrong application also, there is a problem with the structural strength or structural say durability or structural serviceability. So in this case, we can't blame any RMC supplier or any concrete supplier, but whereas precaution shall be taken at site to place the concrete in a proper order by making chutes, and of course all this slurry and all this finer material should be discharged properly and mixed with the concrete, or compaction should be made properly. I have seen one failure at one site. Let me explain you here. At basement level, some footing was being casted, and of course you can see, you can imagine basement is of course below 4 or 5 meter below the ground level. And what does site people did? They they discharge the concrete material in a footings by very short shoot, and most of the concrete was discharged in a footing from the top, very high level, from the 3 meters or something, and they got a very poor strength, and the concrete placed was a very porous. So when we some taken some cores and tested it, there was a failure. So when that case came to me as a as a third party investigator or something, I explained to that owner that RNC concrete was very good, but your application was wrong, because you do not deliver or discharge the material from very higher level of the mixer. Why you are not provided chute to come down the concrete with all the ingredients, that finer paste, cement paste, fine aggregates, coarse oxide together, and all the mix come at the site in a proper way. So they accepted all these mistakes, and they got it rectified with grouting and something. So here I again and again explain to all these people, all these attendees, to use fresh concrete either made at site or you got delivered by RMC. See here one slide I can show you as a explanatory how things goes wrong when your mix design or something goes wrong at the production level. And why this happens, that of course I'll tell you in next slide. So let me start this video. Please say it, look at this video very carefully. हे चालू करायला पाहिजे ना. हे see dear friends, see here the concrete provided for this slab, podium slab. This person is removing this concrete very easily with the help of this tacha or say hammer, pointed hammer. If this concrete is properly mixed or ingredients like a cement was correct, then this thing would have not happened. We can see very easily he can remove the concrete, and all this powder material is coming out like a only powder material. It has not bonded at all. Look at this video till last, then you'll find there was no proper mix provided. And of course before using it for this particular slab, no one has taken care to check it at site before using it. See here, all this aggregate has fallen here, and see these aggregates are totally free from paste. There is no paste of cement or no paste of any cementous material. It means there was no bond with the coarse aggregate with the cement paste. So these things can be avoided by taking care of making fresh concrete. And of course the users of concrete should also be taken care of, that before using this such type of concrete directly into the formwork, they have to test at site or they have to observe the quality of material. Of course that expertise is required to understand nature of concrete, and then only they can judge whether this concrete is okay or not. So some tips are there. I'll show you here. Hello. See with the help of this video, you would have observed the concrete which was supplied at site was not proper. But generally people check only on these slump values, and they say the concrete is okay. But I want to tell you, if you have to observe the fresh concrete like this, when your concrete looks a very whitish and not a grayish one, so then you should raise the doubt. It may be content high amount of fly ash or something. And if it is more darker, then you can judge there may be use of say other material like GGB or something in large quantity. So instead of using directly, you should cast the cubes. Then either you can reject the material, cast the cubes, and then ensure whether this proportion was good and etc. Or make a small ball of this fresh concrete with hand packing only and throw it upwards up to say 1 or 2 meter. Then let the entire ball come down with the same cohesion and other things. This is a very primer and a very what we can say, it's a thumb rule to test the cohesiveness of the concrete, or whether the fresh concrete is segregated or what. So this tactics can be used to check the fresh concrete and its cohesiveness, etc. See here another picture I'm showing you. The people used fresh concrete at site without checking anything, and of course that slab got sagged, there was a number of cracks was observed, and when we tested it, we found that concrete was not properly. So we told the client to demolish this particular slab and recast it with the good. Of course, recasting any RCC member, that care shall be taken at joints because it's a dry joints. So proper care shall be taken while putting the fresh concrete near the hardened concrete. So these precautions are to take. And of course, before using any concrete for anything, it should be tested properly in fresh state also. And one should have a good expertise to understand its cohesiveness, to understand the segregateness, to understand the bleeding of concrete and etc. That comes, of course, by following regular good practices at site or making trials in a laboratory or a site laboratory. Hello. Secondly, this picture I have kept it here purposely. You can observe there is a after say at the time of executing this extraction of core at site, this paste is coming out is in reddish color. Generally, whenever you extract the core, that paste comes out is in gray color. But then you'll ask me why this reddish color paste is there. This reddish color paste is there because of the fine aggregate that river sand they used. It was procured from some other place. It was containing some amount of some reddish material. This is the one thing. And second thing, the water content which was used to make this concrete was not properly. How we judged it, because the cube was failed, then thereafter we tested all this. Hammer test was not satisfactory. UPV was good, but then again core test was also not properly. Core test also we were getting very less strength. Then one day this contractor came to us with some other cubes, not with the same concrete, but it was some other use. And they said, you don't tell your sir that these are different cubes. Then I came to know there is something wrong. We again taken a core from all these columns, such a columns, and we found again strength is very less. Then further we analyzed all this hardened concrete in our laboratory, and we found that pH value was very less as as per the requirement. And then further when we tested with the chemical analysis, we found this concrete was used for this casting of this all these columns was a little acidic. That pH value was less than about some 4 or something. So I want to explain here, these things happens only because of the use of contaminated water, or anybody, those who are using bore water or well water should take care of testing it properly with all these chemical components and etc. Before using for fresh concrete. Of course, pH value is a very simple test, but one has to perform it before using it for all these making fresh concrete. Here for this slide, I want to explain all these manufacturers that care should be taken properly to discharge the cementitious material in a proper silos. What happens, in a generally this bulker comes in a late night, and either watchman or any other ordinary person, unskilled person, he get discharged this bulker. He don't know which is the cement silo and which is the fly ash silo. He opens, इसमें डाल दो, उसमें डाल दो. So because of such a bad practice, such things are happening. And if different material goes in different silos, then finally your mix design recipe goes wrong, and such problem may arise. So of course it is very necessary to take care to discharge the material in right silos, the right material in right silos. And of course, when the cement comes from the factory, they issue the test certificate, but some amount of powder material or cement you take away from your silo or from bulker and send it to laboratory or check it properly for its cement reactivity, for its pozzolanic reactivity, or for cement strength and etc. as per the relevant code. It's a good practice to test the cement regularly, because when the silo stands in a very hot sun, there is some amount of effect is there. In that case, periodical testing of cement material is also very important. Of course, use of fly ash cannot be done directly. You have to test the fly ash GGBS before using in fresh concrete, and check the properties of GGBS fly ash, whether it gets proper result with as a CR means cement reactivity and pozzolanic reactivity. Then only you can decide amount of GGBS or amount of flash, how much percentage we can use it. Use of PPC is also very important, because all these PPC manufacturers, they add some amount of fly ash is up to 45-50%. I can't say directly, but these are the regular practice. They add it more than 30-35%. So grade of, strength of your concrete or strength of your PPC material, one has to check it properly, and of course all these trial material should be tested before making any fresh concrete to use directly in a RCC frame members. Hello. Then I explained you about this contaminated water used to make a fresh concrete. So take extra care for using well water as well as this bore water. And it's a good practice to have a using of potable water itself. Here we can see in this slide there was a hello. See here this column is of high-rise building. This building is 32-story building in Mumbai area, and this column is at B2 level, means at the bottom level. It resting on rough foundation. At the age of only 3 years, we can see the concrete has spoiled due to corrosion, and see on this spoiled material you can see some amount of reinforcement has stuck with the concrete, and it has spoiled or come out. This thing is happened only because of the, again I'm telling you, use of water, or maybe use of curing water, or maybe the compaction may not be proper. We can't say there is a problem with the RMC or problem with the concrete. There may be a problem with application also, or only this finer material was not mixed properly, and only coarser material might have gone to the bottom of column. So placing of concrete is also very important factor, one which should be taken care for all type of structures, not only high rise but for all type of structures. Here in another picture we can see cracks has developed at the same level, and at the same lift wall or some very big columns, because for high-rise buildings column sizes at lower levels are quite big, in some 1 meter or 2 meter or something, and of course it width is also 230 or 300 or something. So when there is a high volume in for column or retaining wall, or for say lift shaft or something, all the people, those who are working at site, they should take care to compact in a proper way, and of course the casting depth of such a column or this lift shaft or retaining wall should be limited to the 1 meter only, or not more than 1.5 meter, because when your formwork height is more, there are chances of making more and more honeycombs and more porosity, because even though care has been taken, compaction was not being done properly. So to avoid make the concreting for this very heighted formwork, preferably it should be 1 meter or 1.2 maximum, or 1.5 is the maximum, because I have seen very failures of columns because of this wrong practices. People are casting this 2.8 meter column straight away. So this is a wrong practice, can be avoided. In our next slide is a very important here, precautionary measures for multi-story or high-rise structures. Why I am insisting here all these points? Because I have seen many engineers have followed wrong practices of casting the columns and slabs. I don't want to tell any name of buildings or name of project or something, because it's a restriction to us. But in Mumbai area, there was a one building. Of course, it's a high-rise building, about some 20th story or something. That project engineer, what the concrete was suggested at footing level and slab level, he followed the same grade of concrete for all casting all the columns and slab and everywhere. And finally, when it was tested, all this cube was tested, it found instead of M30, instead of M40, concrete strength was getting between M30, 35 or something, but below M40. Then, of course, consultant, they investigated further and they found all these columns were casted in M30 instead of M40. So I request all these engineers, project people, project heads, you keep a practice of studying all these architectural plans, structural drawings, detailing carefully before execution start at site. Don't hesitate, don't make any hurry. Study all these drawings carefully, and what are the points you are having, you discuss with your seniors, discuss with your consultant, discuss with your RMC suppliers, place the proper order of concrete. What happens generally, if it is mentioned M40 and if anybody places the order for M30, then it's not a mistake of RMC supplier. So care shall be taken that right material should be ordered or right material should be used. So this is very important, because before executing any such RCC members, extra care has to be taken whether it has the material has arrived at site is proper or not. Then, of course, part of providing reinforcement, detailing of reinforcement, that is also important, because I have seen this our topic is different, so I not put such a slides which showing a wrong application or wrong placement of steel. A wrong placement of steel for longer spanner beam, longer span beam as well as cantilever portions. So we'll discuss later on. Here I want to tell you to understand properly the grade of concrete suggested by structural consultant for RCC foundation, for RCC columns at every floor level, because for high-rise building, some higher grades are suggested at lower level, and as the structure goes up, there is a change in grade of concrete, and many times the grade of concrete for column is different and grade of concrete for slab is different. So people, instead of providing different material as per structural requirement, they provide straight away grade of slab itself, grade of concrete suggested for slab itself. And of course, there are always different in grade of concrete for slabs, overhead tank, lift shaft, lift machine room, etc. Lift machine room is also important, because there is always higher grade of concrete suggested for at the top of lift machine room, where the machines are being installed, where some pockets are left for making foundation and etc. You always keep a practice of discussing the structural details with your project head, senior project engineers, clear the doubts with project consultants, with your project architects, without any hesitation, and to avoid any wrong job execution. There is nothing wrong to discuss with your consultants, with your architects, with your seniors, to avoid all such a problems. Always ask additional set of RCC drawings from structural consultant with advance or revised copy as per site requirements. Why you have to protect extra copies? Because generally the copies which is followed at site, it is being say it becomes very bad position due to handling of all these oil and gas materials. So always ask additional set of RCC drawings with advance or revised copy as per site requirements. With proper mix design as per specification and specification of RCC consultant drawings. This particular point I am explaining here because for any either high-rise building or for any high-rise structures, people are casting the columns at site itself with the local material, and they place the order for RMC when slab is there, because use of concrete in a large volume. So instead of producing fresh concrete at site, they place the order for RMC. Of course, in Mumbai area, it is a very restricted to use a site material as place is not there. Then dust problem is there, noise problem is there. So all these municipal corporation of Mumbai, Thane, Kalyan, they avoid to use a site mix concrete. But in small quantity, fresh concrete can be produced at site. So while making a fresh concrete at site for concrete, casting of concrete, care should be taken that proper grade of concrete is being produced with the proper mix design. Many times what happens, people take mix design once and they follow it for a number of years and they say, "Arey, हमारे पास तो जूना design है." That is not a good practice. Whenever there is a new material procured at site, it is a standard practice to get it analyzed properly and get the mix design revised or to get the mix design new one. And of course, with that mix design, again have some batch trial with a lesser quantity, cast the cube, see the quality of concrete, see the workability, check the use of your admixture, and then only follow it. Important thing here I want to explain you. At many sites, I have observed that people are storing the chemical admixture in hot sun. They don't cover it with the shade or something. Any chemical admixture kept or any cement bags kept in a hot sun get reduced because of the heat of heat of ambient temperature. That property of chemical admixture gets changed, so you don't get a desired result from that. Important thing, one more thing is here, when your chemical admixture comes from the drum, every time it is necessary to stir it properly before using manually or by using pump with the help of pump if you are batching plant. I have seen people are simply operating the pump on installed on drum and they don't take care of using, I mean stirring the chemical admixture. So what happens, the solid content gets settled and only water content get mixed with the fresh concrete. So because of that also you won't get a proper workability as well as proper strength. So all this care shall be taken at RMC plant as well as at the site itself. Secondly, for high-rise building, grade of concrete for RCC column may be higher than concrete grade of RCC slab. Precaution need to be taken for beam column junction at slab level by providing appropriate grade of concrete required for RCC column at that level. In generally, suppose your grade of concrete for column is M40 or M50 and grade of slab is M30 or M40, generally M30. People don't order for M40 in a small quantity to cast the column first and then some different grade of concrete, say M30, for casting the slab. They place only one grade of concrete for casting the slab, and that beam and column junction gets filled with the lower grade of concrete other than the concrete suggested for RCC columns. And of course, this particular point is not being noted by the consultants. Then in that case, what to do? I have suggested one remedy here to all these project executors at site. It's a simple but very important, and it should be used very carefully. If RCC column concrete grade is slightly higher, say M40 or M45 or M50, and grade of RCC slab is slightly lower, say M30, then instead of, and if you are not using or you are not ordering for different grade of concrete for use of column beam junctions, then if you are having only slab grade of concrete or concrete for slab, then thick cement paste or thick slurry in sufficient quantity. Sufficient quantity means if you are making a very small quantity slurry and pouring it, it won't help. You have to make in a large quantity, or say 1 bucket or 2 bucket, as depending on as per your size of joinery or size of junction. This in sufficient quantity slurry shall be added to the M30 grade or lower grade of concrete which was ordered for your slab, with the proper mixing, and of course pouring this slurry as well as lower grade concrete together. It should be compacted properly to improve to get it mixed with the your concrete of lower grade, which will improve the strength of concrete required for column and beam junctions to meet with the desired grade of concrete for columns. As the cement content increases in your that particular part, of course some amount of strength will be increased. So these tactics can be followed very carefully. And of course these techniques I have suggested to avoid different grade of concrete used for the column at the junction level itself. Care shall be taken that no excess water added in cement paste or slurry to make it more workable. Don't make it more workable, make it just normal flowable, so that you can pour it properly into the junction, or you can mix with the lower grade concrete. These techniques will help you definitely to improve the quality of concrete at junction level, and of course it will give good finish, no honeycombs, no any porosity in that particular area, because many times see there is a junction very congestion steel is provided there. So proper compaction is a very important factor at the column beam junctions to place the concrete properly. Quantity of slurry required shall be as per volume of column at floor beam junction at that particular level. Slurry proportion shall be with water cement ratio not more than 35 and 0.35, because with OPC and 0.30 with the PPC, see you have to use a lower water cement ratio for PPC and up to 0.35 water cement ratio for OPC. All the slurry should be very well stirred with a mechanical stirrer to make a good quality of paste to produce, add in your fresh concrete. See, these are some points I'm going to be explain you at the site when the after this shuttering and centering, reinforcement placed on this seal and shuttering at slab level or at column beam junction level. Many times I observed oil remain as it is with the shuttering, and which is coated with the reinforcement provided. So all such oily material or oil should be cleaned very well with the cotton waste or cotton cloth, so that bond of concrete with the reinforcement should not get loosed, or there will not be any loss of bond with the concrete. So this care must be taken at every site, at every level of RCC slab or beam columns. See, no greasy material, no oily material should be stuck with the reinforcement, because due to this such mistakes, concrete and reinforcement steel bond get disturbed. See here another slides I am putting here to show some RCC panels or RCC components were casted for these precast units. Concrete for precast panel components, special concrete with 6 to 8 mm size aggregates, that below 10 mm aggregate down size we used with the proper design for precast ferrocrete thin elements for dismantleable concrete tents facing sea view at Harireshwar Beach Resort at Raigad. This is very important to tell here because all these our elements are only very thin. It has only 35 mm thickness. This is a view of our resort where all these concrete tents are being has been already installed and it is under use since last 13-14 years. See, these are the some precast components casted for erecting all these concrete tents. These are joinery material. These are all other components required as per design. See, these particular sheets you will find it looks like a plywood sheets or what is it called, other sheets. It's like a cement sheets or something, but these are the precast panels casted with a 35 mm thickness for wall component for all these concrete tents. These I'm explaining only just to show you how the concrete is important for any kind of structure for a durability point of view as well as very effective use for the structural designs. When your design concrete design is very good, we can go with the very sleek and thin structural members. This is the area where we have placed the wall units or vertical wall components. See, this in this slide we are showing this vertical components which was cast in a yard, which is under erection at site, and in background you can see the other structures which is already erected properly as per the different components. Here another picture we can see this corner portion is ready with the I mean this erection is undergoing on, and this corner area is packed or erected in part, and behind that you can see the sea area, totally sea area. These particular tents are facing the sea. In this slide we can see the thickness of all these wall panels are only 35 mm, not more than that, and all these vertical panels are taking entire load. That end portion height is some 2.8 meter because that is not more than 7 or 8 feet, and which are taking the entire load of roof without any single support, because of that vertical panel comes under the not only it carries the load as well as it carries the maximum bending moment also. Maximum bending is there, but nothing is wrong, nothing has bent till today since the structure is under use since last 14 years. This particular slide it shows this is a roof of roof from inside of the tent without any central support. All these concrete ridges have supported with the central MS plate placed in a proper way. It is designed properly to hold all these ridges together, and all these ridges again carrying all this roofing material, roofing sheets, which has a very high amount of self weight, and all these tents are standing very well without any problem, even though there are 14 years has happened. In this recent cyclone, nothing has happened with our structure and it is intact. Even before that, 2-3 small earthquake was happened in that area, but nothing wrong went on there. See, these particular structures where this all these precast components are there, used for all these resorts or tourism place. And this in another slide we can see, another picture we can see, owner has provided extra roof over this precast roof, just to increase the area of roof, to have a shade or something, and to have a cover on sit out area. But with this additional load, nothing has gone wrong with the original precast roof. And of course, this particular roof and all components have a very thin thickness, very thin. It's a 35 mm only everywhere. And this particular presentation I had presented at IIT Roorkee for all these precast components, and most of the people appreciated it. And some officer was present from this Himachal area. He called me to give some order, but since that order was very small, I said make it larger, then only it's possible us to cast the components at in Maharashtra and deliver at site in Himachal Pradesh. So because of all these financial aspects and some transportation, we could not fulfill that order. So these are the points I want to highlight, that how the concrete effectively can be used for any RCC member, either it may be for high-rise, either it may be for industrial buildings, or either it may be for smaller buildings. If we are taking care of fresh concrete, hardened concrete, everything will go fine. Nothing will happen any wrong things. All the problem arises for the structures. Majorly it's because of the application, and very few because of the mixed design or something. But major problem happens at site because of the job execution. So I request all these engineers, site engineers, to take care, extra care, to execute your job in a proper way, in very effective way. Then only we can get a very good result of all concrete. Important thing here I want to tell you, the importance of concrete is that, suppose any designer says I want to erect the structure with steel only, he can go with the steel column, steel beams, steel metal flooring, I mean steel sheet flooring, but he has to provide some amount of concrete for foundation of all steel columns. So anyone cannot avoid a concrete use of concrete for any kind of structure. So we have to understand concrete is a very important component or very important material in a construction industry for all industrial, commercial, residential, or see any sort of construction. So I think in a very short time we have explained some points to the best of my knowledge, and of course our whole subject cannot be covered very well in a very short time, because there are number of issues and we have limited time. And of course with the limited time, how much possible to explain you and give some better tips that I have tried. I think you got some points which are helpful while executing the project. I say thank you very much for being a patient with me and for attending this webinar for more than 1 hour. I sincerely hope this pandemic situation resolves very soon at the very earliest, so that we can again meet together with new seminar and with new topic to discuss in detail and share our experience, knowledge with each and every members in person. Thank you very much to all attendees. Thank you very much, Kaushika sir. Thank you very much, Aishwarya ma'am, to handling all this situation and conducting this webinar very successfully. Thank you very much. We'll meet again. For any or further query or for any further discussion, please note down my mail ID, my mobile number, or note down Kaushika sir's mail ID, his mobile number, and etc. So we can meet again. Thank you very much. Thank you everybody. Have a nice time. Have a nice day.
Good afternoon. We appreciate your time. And on behalf of Qcrete Readymix India Limited, our director, Mr. Biju Matthew, will speak a few words.
Good afternoon, sir. May I take this opportunity to thank Mr. Vikram Tambekar, sir, for your wonderful lecture today. It was so informative, and I am sure all of us have enjoyed. Also, I thank all the attendees for your valuable time and make this event successful. We wish all of you safe and healthy weekend. Qcrete signing off. Thank you very much.
Thank you all.